Ants are one of the most fascinating creatures on Earth. They are tiny but incredibly smart when it comes to finding their way. No matter how far they travel from their nest, they almost never get lost. Scientists have spent years studying how ants navigate, and the secret lies in their tiny brains and special abilities. This video will explore the fascinating world of ants and explain how they always find their way home. 1. Ants use the sun as a compass. One of the most impressive skills ants have is their ability to use the sun as a guide. Even though the sun moves across the sky throughout the day, ants adjust their movements based on its position. This is similar to how sailors in ancient times used the sun and stars to travel across oceans. Scientists discovered that ants have special cells in their eyes that detect the polarization of light. This means that they can tell where the sun is even when it is cloudy. By constantly checking the sun's position, ants can move in the right direction and reach their destination without confusion. 2. Ants leave a chemical trail. Ants have an impressive way of avoiding getting lost through the use of pheromone trails. These chemical signals are released by ants to communicate and guide one another. When an ant discovers a food source, it leaves behind a scent trail that other ants can follow. The more ants travel along this trail, the stronger the pheromone scent becomes, creating a clear path. This trail serves as a roadmap that helps ants find their way back to the nest. If an ant strays off course, it can simply follow the scent of others to return home. Interestingly, ants can adjust the strength of their pheromone trail depending on the quality of the food source. When food is plentiful, they make the trail stronger to attract more ants, ensuring that the colony as a whole can efficiently gather food. This system shows just how coordinated and strategic ants are in their daily activities. 3. Ants count their steps. In an amazing discovery, scientists found that ants count their steps. They use this ability to measure distance. This was proven in an experiment where scientists changed the length of ants' legs. Some ants had their legs shortened, while others had tiny stilts attached to make them longer. The ants with shorter legs stopped before reaching their nest, while those with longer legs overshot their destination. This proved that ants count steps to determine how far they have traveled. Step counting is an essential survival skill, especially for ants that travel long distances. It allows them to return home without relying on scent trails that may disappear due to wind or rain. Some ants also adjust their step count when carrying heavy loads, proving that they have an advanced sense of distance and weight. 4. Memory and landmarks. Ants, despite having tiny brains, possess remarkable navigational skills. They can remember significant landmarks in their environment, such as rocks, bushes, and changes in terrain. This ability is especially useful for species like desert ants, who travel across sandy areas where pheromone trails don't last long. By creating a mental map of their surroundings, ants can find their way back to nests or locate food sources. Scientists suggest that ants store this environmental information in their brains, allowing them to navigate through complex areas with ease. This navigational skill is crucial for their survival, especially in harsh or unfamiliar environments where food and shelter are scarce. Through their ability to recognize key landmarks, ants are able to avoid obstacles and adapt to the challenges of their habitats. 5. Internal GPS system. Some scientists believe that ants possess an internal GPS-like system, which allows them to navigate their environment with remarkable accuracy. This system helps ants store information about direction and distance in their brains, enabling them to find their way back to their nests even if they are relocated. The ability to navigate with such precision is essential for their survival, especially in diverse and changing environments. Ants are constantly updating their internal map by observing shifts in their surroundings. This helps them stay on track as they forage for food and return to their nests. If an obstacle blocks their usual path, ants can quickly identify and adjust to an alternative route. This adaptability showcases the advanced nature of their navigation system, proving that ants can effectively respond to new challenges while continuing to fulfill their roles within their colonies. Their internal GPS system is a fascinating aspect of their behavior and survival strategy. Different navigation techniques. Not all ants navigate the same way. Different species have developed unique methods to suit their habitats. Desert ants, for example, thrive in hot, dry environments where scent trails disappear quickly. Instead of relying on chemical markers, they use step counting and the sun's position to find their way. Additionally, they memorize landmarks such as small rocks to help them navigate back to their nest. This ability allows them to travel long distances across barren landscapes without getting lost, making them one of nature's most remarkable navigators. Army ants, on the other hand, are completely blind and must rely on teamwork to move efficiently. They use pheromone trails to stay connected and follow the movements of their colony. These ants travel in massive groups, forming living bridges and pathways to cross obstacles. Their cooperative behavior ensures that no member of the colony is left behind. Meanwhile, leafcutter ants have a different approach to navigation. These ants cut and transport leaves back to their nest, where they use them to cultivate fungus for food. Their foraging process depends on well-marked trails that guide thousands of ants efficiently between food sources and their underground colony. What can humans learn from ants? Ants' navigation skills are so advanced that scientists are studying them to improve human technology. These tiny creatures use the sun, count their steps, and rely on chemical signals to find their way. Their abilities can inspire better GPS technology, especially for space exploration, where traditional satellite signals are unavailable. Scientists believe future robots could navigate using ant-like techniques, improving efficiency in remote locations. Additionally, ants move in highly organized traffic systems, rarely experiencing congestion. Studying their movement patterns could help city planners design better road networks, reducing traffic jams and improving transportation safety. Another area where ants provide inspiration is search and rescue operations. Their ability to navigate difficult terrains could help scientists develop tiny, autonomous robots that move through disaster zones to locate survivors. These robots could be especially useful in earthquake or collapsed building scenarios. Furthermore, ants exhibit a remarkable behavior known as swarm intelligence, where they work together efficiently without a central leader. This teamwork principle is being used to improve artificial intelligence, making machine learning systems smarter and more adaptable. By analyzing how ants share information and cooperate, researchers can create AI programs that function more like natural systems, improving problem-solving and coordination in robotics. In conclusion, ants may be tiny, but their navigation skills are extraordinary. They use the sun, chemical trails, step counting, and memory to find their way. Different ant species have developed unique methods to adapt to their surroundings. Scientists continue to learn from ants, hoping to apply their natural abilities to human technology. The next time you see an ant carrying food, remember, it is following a well-planned path home, proving that even the smallest brains can perform amazing tasks. Ants are proof that intelligence comes in many forms. Their ability to navigate complex environments with such precision is a reminder that nature holds many secrets waiting to be uncovered. These tiny creatures have much to teach us, and their remarkable abilities will continue to inspire scientists for years to come. If you enjoyed this video, please subscribe and support our channel. We greatly appreciate it.